So in the previous lecture, we talked about a single period case uh, for present value and future value. Uh, Now we're going to talk about a multi-period case. So the general formula for the future value of an investment over many periods can be written as future value is equal to the present value multiplied by 1 plus the periodic rate or the interest rate to the power of t. T is just the number of periods. So you may have seen this formula where we used n instead of t. So n, p is the present value, r is the appropriate interest rate or required interest rate, and t is the number of periods. So if this were a 5-year calculation, t would be 5. If this was a 60-month calculation, t would be 60. So we'll talk more about adjusting the rate for different periods of time. So if we're going to, for example, if we're for 60-month example, if we that's 5 times 12 is 60. We're going to need to make our rate into a monthly rate and divide it by 12. So we'll see examples there. So multi-period future value case. So stock pays a dividend of $1.10, and it's expected to grow 40% per year for the next 5 years. What will the dividend be in 5 years? So it's to the future value of the present value. So present value is our $1.10, and then 1 plus the 40%, and then t is 5. So that's $5.92 after 5 years. Probably all wish we could invest in a stock that would with dividends that would grow that fast. So future value and compounding. So notice the dividend in year 5 is considerably higher than the original dividend, plus 5 increases of 40%. So $5.92. So what we see over here is a simple interest calculation. So we have the original dividend and times multiplied by 40%, and that occurs 5 times, and then we add our principal back. So that, without compounding, that is $3.30. So the benefit of compounding is the difference, $5.92 minus $3.30. So begin to see the importance of compounding. So we look at our example. So this is we start out at $1.10. It grows at 40%. So the next year's dividend is $1.54. So the following year is grows from $1.54 to $2.16. So each year effectively we're multiplying by 1.4. So in this case would be 1.154 multiplied by 1.4 is 216. Also 1.1 times 1.4 squared is the same result. Add 40% to 216 and we get $3.02. 40% to $3.02 is $4.23, and 40% added to $4.23 gives us $5.92. Gives you a good idea of the benefits of compounding. Obviously, a 40% growth rate may not be necessarily be realistic for a stock, but could be for some for short periods of time. So present value and discounting. So how much would an investor have to set aside today in order to have $20,000 5 years from now if the current rate is 15%? So the example here, maybe saving to purchase a house or saving for some sort of other investment purchase, so forth. So we're taking the cash flow in 20 years. We're going to present value that at 15% for 5 years. So that's 20,000 divided by 1 plus the interest rate to the fifth power. And that gives us $9,943.53. So if you deposited $9,943.53 today and earned 15% compounded annually, you would have $20,000 at the end of 5 years. Next, find the number of periods. This is one of those things. The finding of periods and solving for the yields is one of the many tools that is available in your calculator, and that will make this much easier. So we'll show you how it calculates. There is a shortcut available for calculating number of periods. It's called the rule of 72. And I will show you. That's basically 72 divided by the rate will give you the approximate amount of time that it will take for an investment to double. So, example here, we deposit $5,000 today. They paying an account paying 10%. How long will it take it to grow to 10%? So what we're asking is setting $10,000 equal to 5,000 times 1.1 to the t power. So we can divide the 10,000, divide both sides by 5,000. So this cancels out. So in our 10,000 divided by 5,000 is 2. So in order to solve for the t, we have to use natural logs. There is a natural log function on your calculator. I'm going to show you in just a second how to do this calculation in a much easier way. So we take the t is equal to the natural log of 2 divided by the natural log of 1.1, and that's 7.27 years, which is roughly what we got here. I apologize, my writing's on top of this, but let's jump over to the calculator and show you the easy way to go about this. All right, so okay, so we've got a $5,000 investment. See if I can. So $5,000, that's our present value. The rate is 10%, so 10 IY. The zero payment and 10,000 future value. Then we just compute, and 7.27 years. A whole lot easier than using natural log function. One thing to point out, when using the time value money keys, the book shows it using this clear time value money function. I do not use that. The way I overcome that is I will, every time I do one of these calculations, I'm going to enter 4 of the 5 NIY PV payment or future value, I'll enter 4 of the 5, and I will solve for the 5th. And then notice, you might have noticed before, I entered 0 for payment. So I can do recall payment, and so I entered 0 here. It didn't tell me that the payments were, didn't tell me directly anyway that the payments were 0, but based on the wording of the problem, I was able to determine that. So